Okay, we're live. Let's see. YouTube's up. Is LinkedIn up? Mm, 1 second, guys. Yeah. Okay, LinkedIn's up. YouTube's up. We're ready. All right, we're back. Hello, everybody. This feels very weird. I haven't done this in a long while. So a lot has happened since last time. Um, so last time I think we finished doing the load balancer that I was working on, and I posted on LinkedIn. I had to take a break because I was planning my move here to Toronto from Thunder Bay, um, and now I'm here. I'm here in Toronto. I've been here for a month. I think since June 8th, so I guess the month is in a couple days. Um, and it's been, yeah, very, very busy, hectic month, not gonna lie. I just started a new job, as you might have seen if you follow my social media. I had to, I was doing the whole move, and that took a while as well. Um, I traveled for a little bit to Montreal. I traveled for a little bit to the States, to Vancouver. I had some friends over, for the last 3 weeks, I've had people over at my house, just visiting. It's been very, very nice. I thought it was gonna be very, lonely moving to the new city. But I feel like I spent the most of the time with friends. Like I've had friends come visit me, all the time. So it hasn't been it's been pretty nice, to say the least. Um, but yeah, we're back. I wanted to get back to streaming. Originally, the purpose of the streams was to sort of put myself in a schedule to work on professional development stuff, practice my technical skills, practice my communication skills, and sort of be, how do you say it? Have somebody to just look out and, well, not necessarily somebody, because sometimes I'm streaming to zero viewers, but at least have some accountability to my process and to continue developing myself. And so I mean, I guess you might think that this is tied to just job search, and now that I found a job, it'll stop. But I think it especially shouldn't stop now. I am more busy now. I'm working like a 9 to 5 every day, but I still want to continue to do this. I and especially now I've just started this new job, and I want to hit the ground running. I want to sort of become the best engineer I can be in as little time as possible, and distinguish myself in the company. So I think this is especially important right now for skill development and, yeah, upskilling. Um, Before we start, I'll preface, and you might have seen this in the disclaimer, but I'll preface the stream by saying that anything I express from here and out during the whole stream, anything I express here on any of my social media, is only my personal opinion. It does not represent the views, interests, or any sort. I'm not representing in any capacity my employer, Sodi Inc., or Lakehead University, which is also my employer, I guess. Um, yeah, so I just wanted to preface by saying that I am not a representative of any of those companies. I am speaking here just for myself. But I can and will share my experience of what it's been like working in both of these places. If any of you have any sort of questions, I can answer to a certain degree. There are things that I obviously can't answer. Um, but once again, all of these are my opinions, and they do not represent these companies at all. Um. Okay. So how do I want to do this? Okay, I'll do some housekeeping. So like I mentioned, okay, for the maybe I'll just start from zero. So I just introducing myself a little bit. Sometimes there's new viewers. My name is Martin. Actually, my name is Martin Morales. I am a recent graduate from LeetCode University in the computer science program. I graduated back in December, and from December until like May, I was job searching for my first job post graduation. And no, I'm actually at the gym, Fatima. Like, can you tell? Like, here, look at all these weights. I don't think I have a dumbbell or anything. Look at all these heavy weights I'm lifting. Um, Yeah, so for those of you who don't know me, my name is Martin Morales. I'm a recent graduate from the computer science program at LeetCode University. And I was job searching and from like December until May, where I actually found a job. I just recently joined SODI in June 15 as an associate software developer. And talking a little bit about SODI. SODI is a mobile and IoT um, solutions company. They sell software as a service for companies. It's like an enterprise mobility management solution. So I sometimes it sounds like a lot of jargon. To put it in simple terms, one of the use cases of SODI software is if, for example, for Amazon drivers that like they have like these little tablets, for example, to complete deliveries. Amazon wants to be able to manage all those tablets from a single point, or like manage them easily without having to collect them and do physical updates and stuff like that. So SODI provides software to be able to manage all of these devices and look at analytics about, let's say, the battery level, or provide like updates, install packages, do remote control, and all these sorts of things. You can look more about it at www.sodi.net. Um, yeah, just take a look at the webpage. They're a very interesting company. I've just been learning a lot about them on my very short time there, and I'm really liking it. So yeah, like I mentioned, I joined as a software developer, and I've been there for a month, just kind of getting the reins of all this stuff. Um, but yeah, so I mentioned that just as like a short introduction, but also to talk a little bit about how the streams are gonna change from now on. I took a little bit of a break for a month, and before that, I was trying to stream 3 times a week for around 3 hours. With working like full time, I don't think that's no longer feasible. I mean, it's possible I could do it, but I'm gonna be very, very tired, and I don't want to do that because otherwise I'm gonna get really tired of doing these streams. So the plan's gonna change a little bit. I'm gonna try to still continue to stream frequently, but it's probably gonna be shorter. Like just today, I was there at the office for like 8 hours, and my commute is like an hour to get. The office is based out of Mississauga. I'm living in Toronto. It takes me like an hour to get there. I get like I'm right now. I'm pretty tired, so I'm gonna try to keep these kind of short, but still like keep relatively like good consistency. And I think that's the best path moving forward. So far for this week, I've scheduled something for Monday and something for Wednesday at 7 p.m. And yeah, I'm really excited to get back to it, maybe with a little less intensity, but I think consistency is key, and just like professional development, like it just kind of like gets you in like the mood and of like getting like getting used to and like having good habits. Um, and also, um, it just kind of helps with like remembering stuff, because if you do things very intensely but very infrequently, then it's harder to remember. So if you're doing them more frequently but in less intensity, it also helps. That's kind of the plan. I'm just going on a lot of rants right now. That's kind of the plan of going with my French. like same thing with like the streams. It's like I can't do it as the same intensity I was before for learning French. So now what I'm doing is just on my commute to work. I'm just reading 1 or 2 pages of a book in French I'm reading, listening to French music, trying to consume content in French, but not sitting for like 1 2 hour sessions of studying because I just simply don't have the time anymore. But yeah, without further ado, I think I've introduced everything I wanted to introduce. Um, we'll do like a little bit of the ritual I always go through, and that is 1 second. Um, hmm, 1 second, guys. Oh, oh, I see why. Okay, that makes sense. So that's fine. But then this is gonna be to this display. Okay, yeah, so my setup is a little bit different. I should have checked this before stream. I don't have 2 screens at this moment. Before I used to have for the stream, I used to have 2 screens. But now one will have to do. So I'm gonna try to read chat like every now and then, but I'm not gonna have it like on my second screen. So if I miss something, I'm sorry. Actually, I'll try to put it like on the side or something. I don't know if it'll pin. Nah, it does not. Okay. Well, what are you gonna do? I'll just check every now and then. So, oh, sorry. Before I start, Lorcana card of the day. Let's see if this still works. Okay. Actually, I need to check the script to see if it includes the new set. I think it does. Actually, let's check. Why not? It includes up to set 12. Okay, perfect. Set 13 is about to come up. When it does, I'll change it. But for now, this is good. Alrighty. So Maleficent, Mistress of All Evil. It's a 5-cost thinkable. And just kind of restating what we're doing here. Every stream, I just kind of try to do like present a random Lorcana card. Lorcana is a trading card game similar to like there's like the Pokemon cards. There's cards for like Disney characters. And I try to introduce like one random card just as a fun thing to do at the beginning of the stream. It's something that I'm kind of passionate about. And so yeah, I just want to introduce people to this hobby. So Maleficent is a 5-cost inkable. Inkable means you can use this card as a resource. You can put it down in your what is called your inkwell, and it's you use that ink to pay cost. But once you put it in your inkwell, it just stops becoming like a card with text and everything and like stats. It just becomes like a resource. So it's a 5-cost inkable, and it's called Maleficent, Mistress of All Evil. It has 2 strength. This is like the attack, if you know from other card games, and 3 willpower. This is like the life of the card, the defense. It says whenever this card quests, you may draw a card, and during your turn, whenever you draw a card, you may move 1 damage counter from chosen character to chosen opposing characters, and it quests for 2. It's the artist is Grace Tran. It's card 51 out of 204 from the English, the 3rd set in English, and it's a legendary rarity. This card is pretty bad. And the reason why is it's too expensive. So it's good that you draw whenever the character quests. It's like a nice plus. But for a 5-cost, the 2-3 stat line is kind of underwhelming. Like you can just kill this with like 1-cost, 2-cost characters. And then the requirement to draw a card, you require the card to quest, which puts it in a vulnerable position already, so it probably is gonna get removed as soon as you quest. It does quest for 2, but a lot of 5 costs quest for 2. And then this moving one damage counter from chosen character to chosen opposing character, I guess it's nice, but it doesn't come that often. So it's not a good strategy to rely on. There's much better cards in purple. So it's not an amazing card, but it is the Lorcana card of the day. Okay, and today, nope, not Hacker Rank. Today we're gonna do some Grind 75. We were doing Grind 75 before I stopped, and we're gonna continue. So we're gonna do K closest points to origin. Let's give it a read. So once again, this section today is just we're gonna do some LeetCode problems, which are problems that normally companies use to test you for interviews. They're like for like technical interviews, they ask for them. And so we're gonna do some LeetCode problems. They're very popular. If you're in the tech industry, you should know how to do LeetCode problems and practice. Fun fact, they didn't actually ask me LeetCode problems for my interview at Sodi, but I mean, it's still nice. It's still nice to know. A lot of companies still ask for them. Given an array, so K closest points to origin. Let me actually go into my directory. Yeah. K closest points to origin. It says given an array of points where points I, xi, yi, so if it's like a coordinate with an x and y axis, an x and y point, represents a point in x and y plane, and an integer k. Return the k closest points to the origin. The origin is 0.00 right here. The distance between 2 points in the xy plane is the Euclidean distance. So if you know from the Pythagorean theorem, how to find the distance between 2 points, I'm just going to go over it shortly. Say you have a point here and a point here. How do you find, let me do this in another color. How do you find this distance? I mean, it should be a straight line. Let's just straight line. How do you find this distance? So what you do is, I mean, this distance is very, like, I don't know, there's not an easy way to find if you're just giving like the x and y coordinates. So let's say this coordinate right here, let me do this in black, is 1, 1, 1, and then this coordinate right here, just to make it easy, let's say 2, 2. So the way you find this distance is you find this distance right here, which is very easy. It's just finding the difference between the x coordinates, so 2 minus 1. And then you also find, okay, so you find this distance, which is 1 in this case. And then you find this distance, which also happens to be 1. It's just the difference between the y-axis coordinates. And then you do a little Pythagorean theorem. If you don't remember, just need a refresher. Pythagorean theorem says if this is a triangle, right? This is a square triangle, rectangle, I think. So if this is side A, this is side B, and this is side C, Pythagorean theorem says that side C is equal to the square root of a squared plus b squared. So that's how you would find this point. So you find the length of this line, which is the difference between the x coordinates, and the length of this line, which is the difference between the y coordinates. And then you square them both, and you take the square root of that. And that's how you find this line right here. So that's the formula we're given right here. So x1 minus x2 is squared. Note that here it doesn't matter which one is x1 and which one is x2, because the difference squared is always going to be the same, whether it's positive or negative. So here, if I take 1 minus 2 is minus 1, and minus 1 squared is 1. 2 minus 1 is 1, and 1 squared is 1. It's the same, because when you square them, there's no negatives. You may return the answer in any order. The answer is guaranteed to be unique, except for the order that it's in. Yeah, so I think it's pretty simple. I don't know why this is a medium. but I mean, let's try it. And I see here we have these directories. I'm thinking of where to put this. I could put it in math. I think just for the sake of this, you can do it in other ways. But I'm gonna create a directory called heap. And we're gonna create heap slash 973.cpp. Okay. And then let's copy this. And so how are we going to solve this? Let me clear this up. Okay. How are we going to solve this? So as I may have hinted just now, we're going to solve it using a heap. And what is a heap? A heap is a data structure that allows us to find the least or the minimum or maximum element in a list, in like a group of numbers, in all of one time. And so okay, let me just go back a second. So the way I was saying that like there's multiple ways to solve this, and like probably using a heap isn't the most efficient solution here, but it's pretty efficient, is because how I would solve this if I wasn't using a heap is I would find the distance between the origin and all of the points and put those distances in a list, and then I would sort that list and return the k closest points, so that I return the ones the k least numbers. So I sort it and then I return the first k numbers, because those are going to be the ones with the minimum distance. We're finding the k closest points. So I'll reiterate that a little bit. So let's say we have these points right here. So we can't just put the points in a list and sort them, because that's not necessarily going to be the closest distance. We can do, yeah, I mean, for obvious reasons, it's not going to be the shortest distance first. So let's say, for example, if you have points, let's say 5, 0, and 0.1, 2. If you sort them, it's gonna put 0.12 first and 0.50 second. When they're actually, well, actually for this example doesn't matter, but imagine it's 1, 3 instead. So it's gonna put this point first because it has the 1. It compares 1 and 5, and it sees 1 is the least, and it puts it first. And so if you return the points in that way, it's gonna be wrong, because 5, 0, the distance is 5, and for the distance from here to 5, 0, it's just this line right here, which is 5. Well, the distance here is 1 squared plus 9 squared is 10, but plus 3 squared, which is 10, and then the square root of that, so it's square root of 10. Actually, this is smaller. Huh. Okay, yeah, because it's 3 point something. Okay, let's say it's, honestly, it doesn't matter what this number is. It can be like 100. Let's say it's 110. So it's going to be 100 plus 1 is square root of 101. So it's going to be like 10 point something. Well, this distance is 5. So it's going to sort them incorrectly. So you can't just use the points and sort them. You have to sort the distances. So what I would do if I wasn't using a heap is find this distance, find this distance, find this distance, and find this distance using the Euclidean formula. And then put them in a list. So I'll put, let's just name them A, B, C, D. So let's say they're in order of length or whatever. So let's say I put them in like C, A, D, B. Then let's say my K is 2. I'm going to sort this list. So let's say after sorting it's A, B, C, D. And then I return a sublist with just these 2 elements. And those are going to be the ones with the minimum distance. But that's not what we're doing here. what we're gonna do here is use a heap. Actually, I can keep this. And let me not go into the details of a heap. All you need to know is you have some sort of data structure. It stores some numbers. And so you put in numbers here. So let's say you get the distance A, B, C, D, and it puts them in here. And somehow you're able to do like an operation, let's say it's pop, I don't remember exactly what the name is, and it gets you the minimum or maximum number. However, you can't search through the list easily. You can't, insertion is not like an array where just append it at the end and it's O of 1. Insertion takes O of log n. Deletion takes O of log n too, but retrieval of the maximum or minimum element is O of 1. So normally you want to use a heap when you're doing a lot of updates to your list, and then you're also getting the maximum or minimum in the list at the same time. You're doing queries in like this order, because if let's say you're using the sorting approach, sorting a list takes n log n time, right? And so if you're having to sort a lot of the time, so let's say you have a list of like this list of numbers, and then you insert E, and then you ask for the minimum element, so then you have to sort the list, and then you insert F, and then you ask for the minimum number, so you have to sort the list again, and then you delete C, and you ask for the minimum number, so you have to sort the list again. So that's going to be n log n plus n log n plus n log n. And so if you do this, let's say one time for each element, it's going to end up being like n times n log n, which is equal to n squared log n, which is bad. This is like n squared, pretty much. Like it's big. It's not what we originally wanted. Meanwhile, if you use a heap, then each time you insert an element, it takes you log n instead of O of 1. When you're starting in an array, if you're starting at the end, it takes, let's O of 1 if you allocate enough space. And you're starting at the end, it takes O of 1. Instead, it's going to take us more. It's going to take us log n. So, but we're able to get the minimum element in O of 1. So if we go back to the example, and we have to, in this case, we don't have to sort. We remove sorting entirely. So we're inserting, let's say we're inserting n elements. So then this complexity becomes n log n, because it takes us log n time to insert an element. And then you're inserting n times, that's n log n. And then retrieving the element is just O of 1. So let's say times plus O of 1, and let's say we also do that n times. So it's n log n plus n. And so this simplifies to n log n, which is better than n squared log n. Does that make sense? No? Okay, well, you don't have to go into like this specifics. Just know that a heap is something that you put some elements in, and then it gives you the minimum element or the maximum element in O of 1 time. Okay, so I need to remember how do you do a heap in C++. Okay, so you just do a vector and then you do make heap. Okay. So we're gonna create our vector, and it's gonna be called HP for heap. And then we're just gonna leave it as is. Then for vector, why did it just do that? For vector int point in points, then what we're gonna do is we're gonna get the distance. So let's make like a formula here to get the distance. Let's get a let's make a like a function here to get the distance. So int, should this be a float? This should probably be a float. No. So, okay, we're gonna simplify this problem. Okay, so I'm thinking about the constraints. So here in the constraints, we see that the number can go from -10 to the 4 to 10 to the 4. So what I was thinking of doing to not use a float, because if you use a float when you're doing square root, you can get floating point, like you can get decimal numbers, right? So I was trying to simplify that by just not doing the square root operation. But if I don't do the square root operation, then the maximum number I'm going to get is 10 to the 4 squared, because it's from the origin to 10 to the 4. And, say, so does 10 fit in an int? Yes. Okay, well then, yeah, I can do a square root operation. Wait, no, actually, it would be 10 to the 4 squared. Does 10 to the 4 squared, so 10 to the 8, fit in an int? Can go to 10 to 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it does fit. Okay, so we can do an int. I mean, worst case we could do a long, but so int get distance, and actually we don't get the distance, we get the distance squared, but it matters for all intents. And you're gonna get 2 points. So vector int p1 and vector int p2, and here we're gonna use that formula. How do you do square root in C++? Security? Security, okay. Actually, we're not doing square root, so it's fine. So, we're gonna return just p1 0 minus p2 minus p2 0. So the difference in the x coordinates squared. You need to use pow, okay. So we're just gonna multiply it twice. Y around that, and then doop, doop. So we do that number squared plus the other number squared. So we're gonna go yt plus, and then we're gonna change this to 1. So it's going to be the difference between the x points squared and the difference between the y points squared, and we're going to return the sum of that, and we're not going to square it. We're not going to take the square root, because that's an extra step that we don't need to do. Okay, we have that helper function. And now what we're going to do is we're going to use that helper function to insert the elements into our heap. So we're going to use, oh my god, I haven't done this C++ in so long, I forget all the operation names. Vector insert, is it insert? No, there's an easier way to put pushback, right. hp.pushback So get, actually we only need to do it to the origin. So get distance to origin. We don't need a P2. And this is just going to be P1 squared. P1 times P1. And this should actually be just P. Why are some of the P's blue and some are not? I feel like I did something wrong. Is P a resource character? Shouldn't be. Okay, so the x squared and then the y squared, because we're doing to the origin, so we're like our second point would be 0, 0 technically. So we're gonna push back get distance to origin of the point. Okay. And now we have those distances inside our heap. We're gonna actually make it a heap now. So we do this. So make heap hp.begin, hp.end, columns. So now we have a heap with all of those distances instead of like actually using like sorting. And now we're gonna return the top k. How to return a subvector to ++. It says just pass the so just pass end idx. Okay, and then so we're gonna just return and actually this is just the distances and we have to return the points. So we can just return the distances. So what we're gonna do here then is we're gonna just do a pair. So it's gonna be vector of a pair of int and then vector of int. So what we're doing here is we're storing the distance here and then the actual point here. Or no, better yet, so we don't have to store as much stuff, we're just gonna create a pair int. And so now, so the first one is going to be the distance, the second one is going to be the index of the point in the original vector. And so here I can't just iterate like this, I have to do int I equals 0, I less than points dot size, I plus plus. We're gonna say int point gonna be equal to points I. We're gonna push back. Oh, we're gonna push back the distance to the origin, and then the second number is gonna be the index. So I. Then we're gonna make this a heap. Actually, we don't. I guess making it a heap is just sorting it, if I'm being completely honest with you guys. Like, it's literally just sorting it at that point. Push heap. Oh, is it priority queue? Yeah, I think priority queue is a heap in C++, and I forgot. So okay, let's do a priority queue then. That's why you're using Dijkstra, which you need a priority queue for. So let's just use that priority queue of pair of int called heap. And then you get push So it makes a max priority queue, but we want a min priority queue. So what we're gonna do for min priority queue is just insert negative distance, minus get distance to point, and I. And so actually here it's not going to be push, it's going to be, and it's going to be pushback, it's going to be push. So this is our min heap. And I'm going to add a comment here. Heap is max heap. Actually, priority queue is max heap by default. Insert negative elements to make min heap. So we insert I, we insert the distance to the point into our priority queue. Once we do that, it should already be sorted. So if we get the top element, which you do by getting top. So we're gonna do that n times. So for int I equals 0, I less than, sorry, not n times, k times I plus plus. We're gonna create an ans vector. Ans. And here we're gonna say ans dot push. Okay, so we get the top. So vector, that's gonna be a pair. Remember there's a way to, I think it's something like this, or is this go? I don't remember. How to, what is that called? How to get elements of a pair into two separate variables. C++. Yeah, like this. Okay. So we do auto. Dist. Dist and point. is going to be equal to the top pair, so HP dot top. We're going to say as a pushback point, and then we are going to do HP dot pop, and then we'll return ans. This might or might not work the first time. I've forgotten a lot of syntax stuff. Expected a semicolon. No viable conversion from value type. Ah. So this is not an int, this is a vector. So this says matching function for call pushback. No known conversion from tuple element to that. Why does it say to pair int int when my because my priority queue is not set properly. So it says an int and then it's gonna be the index, right? Yeah, because I inserted the index here. So this is actually IDX for index, and so this is going to be points of IDX. Oh, okay, that worked out of the box. Oh, this is new. Nice. Okay, let's go to grade 75, and we solved that one. It took me a lot more time than I thought it was going to do. Okay, so just going a little bit over the solution. What we did here was basically we created this function to return not the distance. I named it get distance to origin. It's not actually the distance. To get the distance, you need to take the square root of this. But in our case, it doesn't matter. Like this, like even if you don't square root it, there's still gonna be an order of like least distance to most distance. Just because the square root function is like a not monotonic, sorry, but it's like an increasing function. Like it's not like it goes like this or something like that. So always, the bigger the number, the bigger the square root. So always big squares before you take the square root are gonna be, so if you have to square two numbers squared, and this number is smaller than this one squared, when you take the square root, this number is also gonna be smaller than this one squared. And so we have the function to return the distance to origin, and then we create a priority queue, which is a max heap by default. We go over each of our points. We insert into our priority queue the distance to the origin for that, to the distance from that point to the origin, and we insert the negative of that. So if it's a positive number, it becomes a negative. If it's a negative number, it becomes a positive. We do that so it becomes a min heap, right? If you do minus a number, it's like you flip the sign, so your inequalities are gonna be flipped. And then we insert the index so that we're able to retrieve the pair at the end. Sorry, the vector at the end. Then we create another vector called ans. We look at k numbers, and then we pop from the heap and take k numbers by popping, and that's going to give us the top k. So it's kind of a good example of how a heap works, the operations you do on it, and it's useful for other problems, like for example Dijkstra, which is a very popular algorithm. It uses a heap priority queue. So it's useful to know the operations, which I clearly forgot from last time, but it's okay. And so yeah, if you see here, it's not super efficient, but it works. It beats 50% of them. Probably the sorting like solution would probably be better, but whatever. Okay, I'm gonna solve one more before I leave. I was planning on streaming for an hour. I think I can solve it in like 15 minutes. That's close enough. Oh, okay. Longest substring. Oh, problem number 3. Longest substring without repeating characters. Given a string S, find the length of the longest substring. Substring is a contiguous, non-empty sequence of characters within a string without duplicate characters, right? So what does this mean? Contiguous, non-empty. So non-empty is pretty clear. You can't just have an empty string that's like nothing. It has to have some sort of character. And then contiguous means that, for example, in this string, CAB is a substring. However, BCB is not a string. It's not a substring because it's not contiguous. There's an A in between there. Or BBB is not a substring. And longest substring without duplicate characters. Okay. Let me think a little bit. So let's look at the example. So we have here ABC, ABC, BB. So the output would be 3. That's the length, because the longest substring without duplicate characters is ABC, or BCA, or CAB. There's only 3 letters, so that can be the most length because there's without duplicates. Then here the length is 1 because B just gets repeated. And then here, and it's just gonna be English letters, digits, symbols, and spaces. Okay, I was thinking of something, but given this, I can't do it anymore. And here, the answer is going to be not PW. I haven't looked at the answer yet, so I'm going to try to figure it out by myself. So not PW, that's 2. WKE, I would say is 3. Yeah. Subsequence, not a substring. Subsequence can be non-contiguous, but substring has to be contiguous. Okay. So this is solved with what's called 39.4% acceptance. Okay. What's called a sliding window, I'm pretty sure. I don't know why I just opened that. So what we're gonna do is we're gonna have a string. Let's copy. So P W W K E W, and we're gonna keep a window. And by keeping a window, so we're gonna have 2 pointers. We're gonna have a left and right pointer. So our left and right pointers are both gonna start at the beginning. And so every time I find a non-repeated letter in my current sequence, so my current sequence is just P because that's what's in my window. This is my window right now. Then I check, then I check the next letter and it's W. I check, is W already in my sequence in my window? No, then I can add it. So what I'm gonna do to add it is I'm gonna move this pointer to the next one. And now my window is going to be PW. Then I check the next one. W, is W already in my window? Yes. So what am I gonna do here? So I can't just put it in because then I would have a duplicate and wouldn't fit the conditions. So what I'm gonna do is I'm gonna start removing letters from my window from the left until the condition that there's no duplicates is true. So right here, so my window was this, and my R right now is tentatively here. So now what I'm gonna do is I'm gonna move L to the right one, and then I'm gonna, so my window is now WW. Is there duplicates? Yes, so I have to move it one more. So now it's just W. Is there duplicates? No, because there's only one letter. And then we're gonna keep doing the process. So now we move it here. WK is our window. No duplicates, fine. Then we move it to the next one. WKE, no duplicates, fine. Then we move it to the next one. WKEW, there's a duplicate, so we start moving the L. So we move the L here. KEW. And then we try adding another one, but we ran out of like our array, so our string, so we can't keep going. And so while you're doing this process, every time you find a solution that has no duplicates, you keep track of like the max solution you find. So max solution. And that's going to be equal to every iteration where you find a solution, you're going to find the max of your current max solution and the solution you found just now. So the length, so the distance between your left and right pointer. So if right is here and left is here, this is 3 minus 1, that's 2 plus 1. So we do R minus L plus 1 on every iteration, and that way you can keep the global maximum, or the maximum so far. Okay, so let's copy this. Let's go here. We're gonna make it there. This is, what do I have in array? What? What are these problems? Okay, let's just go look into here a second. So this is to sum. Yeah, that's fine. First bad version is binary search. That's fine. This is like an interval question. It's not really sliding window. This is binary search. And then this is like a flood fill question. I was gonna make it an array, but I think I'm gonna make its own directory because sliding window is a very like popular pattern. That's the word I was looking for. So vim sliding window 3.cpp. Let's copy this, paste it here. New chats? Nope. Okay. So we're gonna have our L equals 0 and our R equals 0. Those are gonna be our left and right pointers. And then while R is less than s dot length, we're gonna keep a max solution, which is gonna be equal to 1. It's always gonna be at least 1, because the strings are never empty as far as I know. Oh. The longest substring without duplicate characters, non-empty. Yeah, but what if the string is 0 length? Then I'm guessing you return 0. Whatever. So here we're gonna say, let's start by doing max solution is equal to the max between max solution and R minus L plus 1. And now we say R plus plus. Increase our plus 1. Oh, we need another component here. Is how are we checking if there's duplicates or not? For this, I'm gonna use a hash map. Another map of character and int. And this is gonna be our hash map. So, and then we're also gonna do something here, which is if hmap.count sr. I guess r could go out of bounds here. So we should do this check. Something like that. So if hmap you know what? I'm here. I'm gonna do if s dot length equals 0, return 0, and then here we can actually set this as 1. Okay. So if hmap.count of this character is equal to 0, then we do hmap hmap of sr is equal to 0, else hmap of sr is equal to hr plus plus, basically. So so we need to add another if here. So here, once we've added sr, before we even add sr, let's do this over here. Else if hmap.count so it does not equal 0, if hmap of sr does not equal 0. So if there's already one of these, this letter is already in there. So what we're gonna do while hmap of sr does not equal to 0, then we're gonna do L plus plus. It's gonna have to equal 0 eventually because we're gonna have to remove them. Okay, so L plus plus, and then hmap of SL minus minus. Actually, we do this first before moving the pointer. And whatever's in here should already be in the map, so we don't need to initialize it. So we just reduce the count and then we move the pointer. And we keep doing this until there's 0 of them. And then we increase this because our window is actually valid now. And our max solution is going to be maximum max solution and the difference. And then we're going to increase R. And at the end, we return our max solution. Nice. Easy. Okay, running a little bit through the solution. So, if our string is empty, we return 0. The substrings are always going to be 0. We create 2 pointers. We create a max solution of 1. Why a max solution of 1? Well, a non-repeated substring is always going to have 1 character because there can't be any duplicates if the substring is of length 1. Right? If you have just an A, there's no duplicates. You need at least 2 characters to have duplicates. Then we create a hash map, and this hash map, it just basically keeps track of like the counts of each character in our current window. Not in the whole string, in our current window. And then while our right pointer is within our string, because we're going to keep moving the right pointer right. If the count of the current right character is 0, if the current right character is not in our string, in our hash map at all, we just create it. We create the count and initialize it at 0. Then, well, this count is not 0 if it was inserted in there already. So like if this didn't run and it wasn't 0 already, it was like 1, but it should be 1 at most. Then we're going to move our left pointer. We're going to reduce the count of our left pointer. We're going to move our window. So the operation is going to be like this. So let's say these are my left and right pointers. This is my window. And my counts right now are P equals 1, W equals, let's say 1. So let's say 2, but the program actually does it differently, so it's easier. Then this is bad. There can't be any duplicates. So we're going to reduce our window. We're going to move the L here. And we're going to reduce the count of whatever was in the L by 1. So count of P is going to be 0. And we're reducing our window. And this pointer is moved. So now we're still with the 2. So we keep doing it until this count is 1. So we move our left pointer here. And our window is decreased. And now our W is actually 1. So good. And then once we have checked that this is a proper solution, because we know that there is no letter in our window that has count 2 or more, then we take the max solution between the length that was already there in the max solution and our current length. Maybe our current length is bigger than the max solution we have found before, so we update our max solution. And we move our pointer right, our right pointer to the right. So like when you do this is when you're accepting that the current window is valid. This is the process of checking that the window is valid. This is the process that checks that the window is valid, because whatever letter we add right now is the only one that can increase the count to an inconsistency, to where a letter is duplicated. We know that previously we already checked that the window had all unduplicated letters, so adding the new letter is the only thing that can make it non-duplicated. So we need to keep removing letters from the left until we don't have any more duplicated letters. So this is the process that is verifying that we have a valid solution, and then we update our count and we update our max solution, and then we move to the next step, and we keep doing that all the way until the end of the array. That's the sliding window approach. You have a left and right, you have a window that you keep increasing or decreasing to check your solutions. Okay, so that's gonna be everything for today. I'm just gonna, while I'm here, I might as well just write the comments, I guess, for the solutions, just explaining it. So this, find k closest points to origin. Idea. Put the distances between point and origin in min heap. Then at the end, pop k elements from the heap. And that's our answer. We need to put the index of the point in the heap so we can retrieve it after, so we can retrieve the points after after popping the heap, after getting the distances from the heap.
What we do here is go back.
And HP top. Okay. And then sliding window right here. Keep a window, so this is going to be length of longest substring. Idea. Keep a window with edges L and R. Make sure our window is always a solution for the problem. And then also maintain a max solution so far that we update every time we find a new solution to the problem. A new possible solution to the problem. I'm going to clarify here. By solution, I mean a substring with no repeated characters. By solution, I mean a substring with no repeated characters. That's one of our possible solutions. We need to find the maximum one. So we keep a window with edges L and R. Make sure our windows always has a solution for the problem. Maintain a max solution so far that we update every time we find a new possible solution to the problem. By solution, I mean a substring with no repeated characters. And so here, I say here, we guarantee that our window has a valid solution. By removing characters from the window until the duplicate is eliminated. Okay. And now we do a little bit status, a little get add period, a little get status again, a little get commit minus m. Add solutions from the console.logs9. And then we're gonna do a little get push. Okay, and then so if you want to check the answers to these problems, go to github.com/thejambot/LeetCode. Right here. These are all my answers to the problems in C++. So feel free to check them out. Okay, so that was around an hour and 15 minutes. I feel pretty comfortable with that. I'm very tired, guys, and I think I'm gonna try to go to the gym now, even though I'm really tired, but I should go. So I'm gonna leave you guys. But thank you for tuning into the stream. I really appreciate it, you following, and if you're not following, then it doesn't even matter to me because I don't do this for the views. I do this for accountability to myself and to keep working. on personal development. But Wednesday, next stream, Wednesday, same time, Wednesday, 7 p.m. Eastern time, we are going to be doing something very exciting. We are going to create a RAG system, a retrieval augmented generation system, in C# that is going to help ask questions about research. So we're going to be able to put some research papers in PDF format into our program and then ask questions about it to an LLM. And this is going to be a local LLM. So we're going to run a local model in my computer. And so we're going to ask questions to it, and it's going to be able to retrieve retrieve relevant documents from its training. I guess it's kind of like post-training from whatever documents we put in the application. It's going to be able to retrieve the most relevant ones and cite them in its answer, right? It's going to be able to cite the documents in its answer. And I think this probably already exists. It very, very likely already exists. I think it's very useful for when you're doing research. You have all your literature, or you're trying to you probably have your literature in like Zotero or something like that. And so you're gonna be able to grab all your PDFs from your literature, put them into the program, and then ask any questions you might have from those PDFs, which I think is very, very helpful if you're doing research and maybe you have questions about like, does any of my literature cover this topic, and can I get sources for it and explanations? Then the system is going to be able to go retrieve the documents that are most relevant to the questions you're asking. So let's say in this case you're asking about research about I don't know, knee injuries. And so it's going to be able to get all the research about knee injuries and answer your question based on that research. And it's also going to be able to cite that research. So it's going to be able to show you in the interface where it got the information from. It's going to be able to pull back a source. And I think that's really cool. But we will be doing that on Wednesday. Well, just starting it. I'm not going to get anywhere close to completing it. But what I want to do on Wednesday is build some sort of system that's able to take PDFs, chunk them into small portions, and then so the program's able to read them into its memory, which is a vector database in this case. So we're also going to need an embeddings model. We're going to need an embeddings model, and we're going to need an inference model. And I'll explain a little bit about how that works on Wednesday. But it's a very exciting project. It's new to me because I haven't used C# and I want to learn because we use it at work. And it's kind of new to me to use local LLMs. So, oh, hey Arjun, I'm literally just about to end stream. So sorry you missed it, but I was explaining what I was gonna do on Wednesday. So on Wednesday at 7 p.m. Eastern time, I'm gonna be creating a RAG system for research. So it's basically you're going to be able to put in, so when you're doing research you have a lot of literature for your literature review, so you're going to be able to put all this in my application and then ask a question to an LLM about all of that research, all of that literature, and then it's going to be able to answer to you with references to those documents and where specifically it got the information from. And this is going to do it through a system called RAG, Retrieval Augmented Generation, which basically, using vector embeddings, is able to retrieve the documents that are most similar to the question you asked. And we're going to be doing this in C#, which is a language that's kind of new to me. And we're going to be using local LLMs. So I'm going to try to find local LLM models for vector embeddings and for inference. So it'll be cool. Oh shoot, I was watching House of Dragon episode 3, it just dropped. Yeah, I kind of really want to watch the Game of Thrones shows. Actually, I kind of have through like YouTube Shorts. I never watched the whole Game of Thrones. but I know like most of what happens. I should watch it at some point, especially just start with like the smaller series, not with like the whole Game of Thrones. Start with House of Dragons, start with Knight of the Seven Kingdoms. Those look really good. I've seen some shorts about them. They look really good, really interesting. Um, so maybe I'll catch up to you and we can talk about it. But for now, I'm gonna go. And I'll see everyone back on Wednesday to build that rag system in C Sharp. I'm gonna try and go to the gym now, even though I'm extremely tired. But it doesn't matter. I I have enough energy. All right. Thank you for joining. I'll see you on the next one.